Right. So setting aside for a moment that we don't actually know how long we have for Octopus. The timeline's going to be
2 years.
Yeah.
Yeah, I mean, most things are pretty bite-sized, minus the intercluster live migration stuff.
Okay.
Needs to get broken down into smaller subtasks, but I plan to do, and then start hacking at them.
All right, well, should we go down the list?
Sure.
The memory copies.
So that's half in. So on the right path, I did a hack. So librd, if you don't have cache enabled, it uses bufferless ability to like install a deleter on a pointer. So I basically reference count the pointer. So once it goes to 0, I block any AO completions until the reference count goes to 0, and then it fires them if need be. So that solves the one issue with the messenger having like 2 copies or whatever.
Okay. Is that in?
It's in, yeah.
Okay.
And so for like large IO writes, you'll see a substantial reduction on
okay,
because it eliminates the mem copy. But on the read path, so that's still not in, and that just needs some generic infrastructure, I think, into the messenger where it can like basically partially decode the message and pass back like,
right.
iterators or whatever to where it left off,
yeah.
and then like the objector can basically then take over and say, yeah, I have a buffer list to put all this data into.
Okay.
And read it off the wire, but I think just the way that the current thing works is, yeah, you can't really pass in like those IO vecs or anything like that into on the read path. It just kind of says, all right, I'm reading into a chunk of memory, and
yeah, that one I'm a little bit nervous about. It really depends on how there was a pull request I looked at a couple weeks ago that was can't remember if it was, I think it was trying to do the right side actually, and I didn't think it was going to work. I can't remember. It wasn't yours though. It was somebody else.
It was probably the guy that did he had a talk at Ceph about improving. Can't remember his name right now, but yeah, improving librd speed.
Yeah.
Yeah, but the right path, I think we're good on the right path. It's just the read path where we have to double copy the data because it's not using the provided buffers.
Okay.
Deep inside the messenger.
All right.
Next one down is semi-related, but the optimized IO path. There's a lot of stuff that's already gone in. It's a lot lower in terms of CPU usage per IOP. The IOPs are higher already.
Mm-hmm.
Can always optimize more, so I don't feel like it's ready to get merged yet. Especially as we start adding new features and start changing things around, that will probably break something and make it slower again.
Is part of that getting rid of object cacher, or is it?
Object cacher by default is gone. It uses a new right around cache. So all it does is it uses the same RBD target dirty memory setting, but it basically allows X number of megabytes of in-flight IO to be on the wire, but it acts it back to the client immediately until it gets a flush. If it gets a flush, then it will actually make sure that anything that's like pending will get written out. And that works in concert with the IO scheduler that Mikola wrote. So that basically the IO scheduler sits on the other side of it. So now if you're able to feed it more IOPS, the IO scheduler can now batch together more things, which was the other thing that the object cacher did with sequential writes, where it could batch them together.
Also.
Yeah.
Cool. All right, RBD MBD.
RBD MBD. So there was another one that already merged in. That was the adding support for Netlink. Next one that Mike is going to work on, which is the single daemon support managing multiple processes.
Cool. Okay. And then intercluster live migration.
Yeah, so that's the high levels, all the stuff we talked about last week at the.
Yeah, so this part actually I got confused in the the CDM discussion because there was there's the current mode, which is the journaling,
Journaling,
mirroring
yeah.
of the journaling. There's a second mode, which is creating snapshots and then copying the snapshots. And then the third one is the
So the
was
one
the
was
live
creating,
migration part.
no, one was create snapshots on a schedule, like an automatic schedule, like every X
Yeah,
minutes or something like that, create a snapshot and let those snapshots be automatically transferred to the other side. And then like
right.
the third mode was
Yeah,
basically just manual, like, hey, take a snapshot now. But then with those modes 2 and 3, I think we'd also want to then be able to support the inter-cluster live migration. So the live migration feature that was added to Nautilus only works on a single cluster, but then be able to
hmm
expand that feature to say,
yeah,
all right, I now want to basically put this image on this remote side in live migration mode. So any IOs up into like the last known good committed fully replicated snapshot has to get served by the remote side. And that remote side, every time you read or write, it'll basically copy up the remaining data to the local side.
I think the part that confused me was I seem to remember a comment saying that you wanted to do 3 before 2, and it feels
Well,
like it'd be the other way around. Like you can
well,
do snapshots and copy
well,
snapshots
so
without doing.
3 is snapshots too, right? So the live
Yeah,
migration goes against 2 and 3, the
right.
intercluster live migration. The 3 is I don't need to schedule snapshots. You just go into the RBD CLI and saying, do it now, versus
I see.
two is
That,
now I need to have like all this command line stuff to say define a schedule, and I have to have something in the background, RBD mirror, saying,
right.
oh, it's time now for me to create a snapshot. I'm gonna go create a snapshot.
I guess.
But
Okay.
the actual transferring of the diff, that all that work still goes into RBD mirror for either
I
mode.
see.
So they're still
But you
both
could
working.
do,
They're both
but you
working
could
off
do all
snapshots.
that without the live migration part of it.
Correct. Yes. Yes. The
Yeah.
live
Okay.
migration is something that can get added on top of, and it would
Got it.
support
Okay.
option modes 2
2
and
and
3.
3. Okay. So would you do the? I mean, the first piece of work that's common to both is that you have to have the that diff stuff happening in RB mirror. Would you add the? Would you do the scheduling for mode 2 before you did live migration for mode 3, or would you do? In my head, it just feels like the scheduling is going to be easier. I'd want to do that one first, but maybe not.
It
Yeah.
certainly probably would be easier than the
Yeah.
live migration. The actual like intercluster, like connect to the remote cluster and read the data
Yeah.
and deep copy data. I mean, we have
That's,
most of the things are there for live migration deep copy. It's just it would be now tweaking it to say, well, now I need to open up another cluster connection. And the big thing that's kind of the unanswered question for that one, because now it's a client that's actually opening up a remote connection.
mhm.
Now, does it mean that the client is using like the same keys that RBD Mirror is using to like go connect to
Yeah.
the
Yeah.
remote side?
Right. Yeah.
I mean, it can, but
It
is
could,
that
but
okay?
yeah. Right.
Or now,
Another reason why I assumed that mode 2 would happen first. but, but yeah. Okay.
but yeah, that was another reason why. Well, if you have like a Rados proxy, we can basically say like the Rados proxy hides all the Ceph stuff because you can do like a mapping inside the proxy to say like here's how I can map local Ceph users to permissions on the remote side or something like that. So now you don't need to worry about key management for any individual client talking to a totally different remote cluster.
Yeah.
Or we can just wave our hands and say we don't worry about key management either because the keys are already in the
Right.
mon in the config store.
Right. Okay. I guess my suggestion would be to focus on the simpler snapshot scheduling and mirroring part, and because there are fewer items in Pandora's box, that's sort of fewer worms, whatever the right smaller can of worms. Um, but yeah, we'll see. I guess how it goes. I have a stupid question because I keep talking about the current live migration feature that's in Nautilus. But I'm not sure I actually understand exactly how it works. My assumption was that you can have an active VM that has a device in use, and you can migrate that image to a different pool. But I seem to recall hearing something about how you have to do like a prepare stage, and you have to like reattach and What?
Yeah,
How
yeah.
does it actually work?
So it's basically fancy clones.
Under the covers, yeah.
Yeah, yeah. But it's clones with the deep copy support. So if you had n number of snapshots on a given uh, thing,
Okay.
it'll handle it. So yeah,
Okay.
the problem being is that, well, we separated in three phases: pair, migrate, and commit, and abort, roll back. But
Mhm.
the the problem being is, at some point in time, you're going to have to point your
Your client
VM or your
recognition.
whatever to the correct new image name, right?
Mhm.
If it's moving.
Okay. And how is that done?
Well, because that's
Yeah,
outside of our purview.
I
That's at a
see.
higher level.
Okay.
Um, I can't remember. Mercola, you're on, right?
So what at the prepare stage, actually we need to stop restart the client. So when we are doing prepare stage, we actually create new image, new headers, new metadata, and at this stage we need the client to reconnect to the new image. After this, actually, it looks like a clone, as Jason said, and just copying the data in the background and so on. And actually, I was thinking about doing it without interruption, just change this in the live client, this headers and so on, but there are some corner case difficult to do, and actually, for example, kernel client is not supporting it right now, and we can make sure that the image is not used by some other clients right now. At least it's safer just to make sure that all clients are stopped. It's how it works right now. We make sure there are no watchers right now when we are running prepare step.
Yeah.
Yeah, it's kind of like those corner cases. So if we knew and guaranteed that the images had exclusive lock, right, we could send an RPC request to the current exclusive lock owner and say, do it, like start the prepare, and it could like do everything it needs. But we don't know if the image supports exclusive lock. It may not. Um, in which case we have no way to actually tell the other client, hey, we're starting
And
a
it,
prepare. Instead, you just change the image and say, hey, a prepare is in process, a migration's in
yeah.
process, and then if something like RBD says like, be like, I don't support that, but it still
Couldn't you
logs it
just
right to the image,
fail to
or
prepare if exclusive lock isn't enabled?
but it narrows the use cases in which it could be used.
Yeah, I guess. Okay. But it seems like it would be nice if for the cases, like imagine OpenStack Nova, for example. I would imagine the workflow would be you do a retype on sender, it would change its metadata in its database, and then it would call out to RBD and says, by the way, live, migrate it. And so from top down, it would change the metadata. So the next time the VM restarts, it would talk to the new image name. There'd probably be a two-phase commit there or something. And then it would reach underneath and then ask RBD to do it. And the running process would see the rename event, and it would just start writing to the new clone as it happens. It would do the prepare or whatever without having to restart. And then the next time the VM
That's
restarts, it
yeah,
would.
I think that's
Once again,
certainly something we could do for if and only if image has exclusive lock
yeah.
enabled, that we could
Okay.
coordinate it. But again, you still run to that final commit stage where commit right now, we delete the original source. You basically get
Right.
rid of the image. And
Right.
if you didn't tell your higher level orchestration layer that the new image is actually over here, even if,
Yeah.
yes, the transient version of, QEMU
Right.
that's running, it knows that because, it read the original source image. And now it was told to go, hey, now go point over here.
Right.
And this is, the original source is now your parent. just temporarily while, this migration is going on. But yeah, at some point there's the coordination problem of
Yeah.
pointing.
Well, I would imagine like the Cinder driver would make sure that it changes its metadata before it calls commit on RBD. But there might be a gap in there where the running QEMU process might do.
Yeah. So my goal
libert might restart it.
So my goal was kind of like, so if you take the Kubernetes case, where basically you can't do anything on a live volume anyway, but
yeah,
if you use like something that says like, hey, create a new volume from this volume or from this snapshot with some special flags that say you want to live migrate it, create it instantly, but your workload is already stopped by the fact that you can't do things on live volumes with Kubernetes. So Cinder obviously makes things a lot more complicated, which adds way more corner cases.
Yeah.
One thing I like about Kubernetes, they really restrict down like what operations you're allowed to do.
Yeah. I was just making the argument that maybe Kubernetes should do this. Because this is a capability that like most storage arrays have, where you have, like, imagine you have a database running and it's, you're the whole, and you decide you want it to go faster. Like, I guess you can restart it, but.
Oh, I mean, maybe the other thing is like you essentially never commit the image, but then you just, you create a chain of live migrations because you can't get rid of the original source image. And then it has all the metadata it needs to know, hey, I actually have to go open this image.
Could do that, or you could. I mean, even if the Kubernetes workflow is like, does the live migration, and its commit is the last phase is where it deletes the head, and so you actually have to make sure you're changed. Maybe it just doesn't do that until it does the live migration, and then when it's ready, it kills the pod, commits, and then recreates the pod. But, I mean, that would probably be the workflow, and your database will restart. But it'll be a fast restart, as opposed to like stop it, copy data, and then start it.
But even right now, it's a fast restart, right? Because it's and instantly start using new version.
Right.
It's live migration with just hiccup of downtime, as opposed to shut it down, copy the whole thing, and then start it up again.
Right.
So either way, at some point, unless you basically say we keep that original image around forever, as long as you don't commit it, you can always open it up by the old name, and it'll, barring KRBD until we add support to KRBD.
Okay. All right, that was a tangent.
All good.
Okay. So live migration, next is client cache read-only.
Yeah, that's almost.
What is this?
In terms of that's the Intel stuff, the persistent read-only
cache. Oh, right, got it. Okay.
So it has a generic daemon like Ceph immutable object cache that runs on a node, and then there's a plugin in librd, there's a caching layer that can talk to it, and then in theory RGW could also add a hook to it, because again it doesn't care, it just caches objects.
Stuff. Okay. KRBD, object map, and fastdiff.
Yep. Ilya, keep saying it's getting close. It's breathing. It'll be in the next kernel.
Cool. RBD mirror.
Yeah, so this is, I don't know if this will make it, but I always like, because people keep saying like, why do I have to resync the entire image? Well, the reason you have to resync the entire image is because Rados doesn't allow me to deep delete an object.
Right. Yeah, we can probably fix that.
If you give me that ability to deep delete an object, we can say, oh, this one object has an issue. Let me delete it, and then let me just repopulate it, because we have all that code to we have a state machine that can repopulate a single image, like, and copy all snapshots and all data.
That seems pretty doable. Let me add a card under Rados for deep delete. Wait, should it be deep delete, or is it like delete clone?
Yeah, either or. Like if I have a way basically on a given object to delete all the clones of that object, or if I can just specify delete this clone, delete this clone, delete this clone of the object, that's fine. Whatever's.
All right, I can do this. That's not that hard. Do it after the snap stuff I'm doing right now, since I'll have snapshots fresh in my head. And then I need to link to the other card. Okay. Port deferring long-running operations to the manager RBD support module.
So I keep trying to get work out of the CSI, and there's use cases coming up about like, well, I want to create a snapshot, but instantly I want that snapshot, potentially to get flattened or something like that. Well, we can't have the CSI run that flatten operation, or if we could, what if it dies in the middle? Who's tracking all these, batch requests, and who's going to restart them after, it restarts? Dashboard does the same thing where, you do a long running operation in the dashboard. If the manager crashes where it's running the dashboard, it just kind of stopped in the middle, and there's no like, redo log about the actions that you said do these, and I, have to, restart them upon failure.
It seems like a persistent work queue.
So exactly, yeah, exactly. Yeah. So just some random objects like RBD to do or whatever that will just contain a list of image ID, what you have to do, some other metadata, and then that support module can on restart can scan it, periodically scan it, say, oh, this worked for me to do, and do it, and provide feedback to say like, hey, on this remove operation, you're 30% done or whatever. Not just that something's in progress, but you actually wanted to get the feedback. So then the dashboard guys, they're interested in also then if that happens to hook into it, and then we can get the CSI to also hook into it for any long running operations. So they don't need to come up with their own like system to keep track of redo logs.
Okay. Is there that reminds me on the RBD trash side, is there a way to make that like the default, so when you delete an image it just automatically goes in the trash?
We do, yes.
Is that okay? Is there like a garbage collector that schedule for how often?
No, so our current garbage collector is added to cron.
Got it. So that would go in the manager too.
But that would go as part of that RBD support thing.
Okay. Okay. Perfect. Should that be on here?
I have trash arm in there.
There it is.
I guess that's really the
built-in schedule for running trash purge operations. Moved it up. Tagged
oh, there we go.
Okay.
So yeah, that's the other thing I want the CSI to do, because removals are slow.
Yeah.
And if the CSI just moves it to the trash, they can forget about it. Also, if it has if it has linked clones to it, doesn't matter, move it to the trash, and you don't have to worry about it anymore. And then eventually it'll get deleted once all the linked clones are, deleted or flattened or whatever.
I guess it seems like we should break this intercluster live migration into mode 2 and mode 3.
Oh, like I said, I got to break it up into tasks.
Okay. And for the mode 2, if we can, I think it'd be really nice if it would work with kernel RBD.
Yes.
I'm not sure how many pieces are necessary for that to happen. I guess it's just the snap.
Well, so
yeah.
So the only problem with kernel RBD, it's not really a problem. It doesn't do any maintenance work, so you'll just have a hiccup of IO as basically the librd client gets the exclusive lock from KRBD, which is great because it just paused all your IO by default, and it creates the snapshot and then releases the lock back to KRBD. So I mean, you can do that right now. So there's nothing magical about creating a snapshot when KRBD has is actually writing to the volume. If you don't have exclusive lock, it'll eventually notice and update its map.
Well, it's really just the object map is sort of the performance piece to make the snap diff work better, right?
Yes.
Okay. That sounds good. All right.
But Vault is running in the background if you don't have object map.
Yeah.
And or man's diff of iterating through.
Okay, so last question. I think you were in. Were you in Florian's talk in Barcelona?
Which
Where he
was
was talking
that?
about
Yeah,
RBD
yeah,
mirroring,
yeah. Yeah.
and he was. I think he thought it was a 10x let's drop when he turned on journaling.
For small IOs, yeah.
Trying to figure out why that would be. I guess they're small random IOs, and so it really is every IO does turn into 2 IOs.
He actually, I don't think he actually had bad as a drop on random IOs as he did in sequential because he had the object cacher enabled. So he was getting
okay.
for the small sequential IOs, he was seeing a bigger delta of speed with journaling enabled and disabled. That's just because it does a great job. The object cacher does a great job of taking sequential IOs and turning it into 500 like sequential ops into one single op on the backside. Are there issues in terms of journaling? Yeah, there's some big ones that were added, especially by breaking up larger IOs. That we didn't have a big memory use on the RBD mirror. That's not going to be an issue with Nicola's changes with memory targets, because then we can basically say like, we know we have this much memory that we can use, and now we can try to stay within those bounds. If we run out of memory, we'll say like, you got to start more daemons up or give us more memory, but we're not going to like basically fail.
And that was a problem because if the journal is short, then you don't have an opportunity to coalesce IOs.
This came up like through testing after like during the Joule release, like, oh, I have 1,000 images being replicated and I'm doing like DD operations on them with like 4 megabyte IOs or something like that. So that means the journal entries are like 4 megabytes times, n number of objects per times 1,000 images.
Right.
Why am I using like 16 gigabytes or whatever of RAM?
Yeah.
So we changed it to be like, well, I think by default, it's after you get past 16K, it starts breaking up write events into multiple journal events, so that the other side of the RBD mirror can limit its memory usage and just like nibble on, but that just explodes the number of IOs. Oh, and the other thing which I talked to Florian about was, but he didn't have time to test conference. But right now we're very anal about not. We basically like issue one for each IO coming in. We issue one like journal append event. So I have a tracker ticket open to say like, well, why don't we add the same option we have for the cache, where it's kind of like you're right through on the journal until flush. So we can then once you see a flush, now we can start batching together multiple journal events, and we don't have to worry about consistency issues because we can.
Okay.
So now we can change multiple into. Oh, and Mikola also has a PR open for aligned appends with BlueStore, because BlueStore could do up to like 3 IOs for an append. So now we'll basically skip past and like align IOs, align appends on the block allocation size, so it can do like 1 IO instead of 3.
Got it. Okay.
So we have things in progress, but they're just like tweaks and not redesigns.
Yeah. Okay. So I think the main thing that I was thinking when I was trying to imagine how it was working and what the problem might be, was the the flush thing, where in principle you can buffer all these things up and until you get a flush. And and then after that also you can coalesce the writes.
Yeah. So right now with the object cacher, the object cacher, it starts. The IOs go immediately to the journal, immediately to the IO cacher. Object cacher, I mean, and it can act the writes back. So as long as like the write back cache is now like filling up, it's fine. Like you're hiding the cost of the journal operations. But when you're doing all these benchmarks against it, you're obviously filling up your 16 megabytes or whatever your default size is of the object cacher. So you're running into that brick wall of the latency. So it looks, I think a lot of times the journal performance looks a lot worse than it actually is, because how many things are just like straight up running at full speed, at benchmark speed, stressing the cluster, you're at the max cache size. If you just have small random bursty IO behavior, I don't think you're going to see anywhere near as bad as
Yeah.
those latency hits and IOPS hits.
Yeah. Okay.
It's one of those things. Well, you only know how bad it's going to be until you test it on your workload.
Right.
And what's your
mileage may
workload?
vary.
Most people's workload is not straight like I want to take up 100% of my Ceph clusters, use
Right.
resources. At least I hope that's not the case.
Yeah. Exactly. Okay. Cool. Okay. Let's see. Is there anything else that we should be worried about here? I guess the RBD, CLI, QoS management stuff might come up depending on how far the QoS stuff in Rados comes along, but that's a sort of wait and see, definitely. So.
Well, yeah, and I would want to also then integrate also the QoS stuff into some of these background operation things because you want to put those at a lower priority versus like client IO.
Yeah, exactly.
But I'm not holding my breath on it. I've been holding my breath for like 3 releases now.
I know. Same here. Okay. Do you have any sense of what the status of the RBD management stuff from the dashboard is in relation to all this? And are there things?
So RBD is actually really well feature complete in the dashboard because anytime there's something missing, I try to go in and try to add it. And then Suze added all the iSCSI management stuff that does all the REST calls out to the RBD target API.
Okay.
So
probably like trash scheduling, trash.
You can get into the trash in the dashboard, but like setting up schedules or something like that, you can't do.
The long-running operations, if that happens, having some visibility there.
Yeah, exactly. And then the RBD mirroring those other new nodes, adding those hooks into the dashboard.
Cool. Okay.
But all in all, I think RBD is already pretty.
We're in good shape.
Well integrated into the dashboard.
Awesome. Okay. Sounds great. Now we just need to figure out whether this is all done in November or March.
March.
Yeah,
No one's gonna use Octopus if it comes out in November.
Yeah, I was totally convinced, and then that person started emailing and saying, in China, nobody will deploy anything for November, December, January, February. So you should do it. I was like, great. I'd be happy with March. Okay. Cool. Sounds good. Anything else?
Anything else for anyone else on the line?
Mike, you're going to be working on the NBD thing, is that I heard?
Yeah, I'm working on them.
Awesome. Okay.
Vector kernel, yay!
Yeah.
You got a little kernel in there.
Yeah.
Once you've learned that the NBD driver has major issues, even though we promised it didn't.
Yeah, they're like 300 lines of code or whatever. Perfect as you hoped. Is there I mean, it's all netlink, right? That's how all the I/O is passing over a netlink socket. Or
management is done through netlink or old school iOcto, but I/O is just passed through a normal Unix socket to user space.
Okay. Is there any opportunity to do anything clever there with like zero copy on the pages or something like that?
Yeah, Mike, implement that new UIO stuff.
I don't know.
Splice,
For
I don't know.
the send side there should be, but for the receive side, it the sockets they still do the copy. But
yeah,
if you can maybe like hack in a splice type thing with do like crazy things with splice.
There was a PR open to do that. I mean, it sucked for small IOs, but for large IOs, to the benchmarks it.
Okay.
But I mean, it got Getty down into bufferless. I can find the PR again. I mean,
yeah. I just remember that it's like 4 years ago, that Russian container company that does hosting, I forget what they're called. They did all this work on RBD to add a whole bunch of zero copy IO path optimizations. Not RBD, sorry, on Fuse. They did all this optimization on Fuse. I wonder if some of those tricks are applicable here.
Yeah, I'll look into it. So it was that same thing that Matthew Wilcox had wanted to create a true user space to kernel
Yeah.
zero copy lock device, and so
Yeah.
I looked into that over my vacation, and yeah, that would be cool to just finally do it instead of adding hacks. But the thing is
Yeah.
with the thing is what we need though, and like Azure and Gluster is, we're gonna pop up to user space, but we're gonna pop down back to the kernel. So we really just want like the data blocks to go from there to there, and then we want to add in, our little header, the Ceph header or
Yeah.
Azure header. So we don't really need to zero copy user space, and then because if we do, we'll still have the same problem that we need to, have the same problem on the back end where we're gonna hit copies in the network layer, or between user space and kernel space. So we really just need to, just pop up user space, hey, add this header to this data buffer, and then have something back in the kernel backend. And so like I hacked it in, but it's not pretty. It's basically like the exact same thing we want to do with iSCSI target too. And so it's always been the dream. And so like we can do it in hacky ways, but to do it in nice ways, yeah, I don't know. So
I thought that's basically
Okay.
what the splice stuff does. It only reads as much as it needs, and then kind of like just forwards the rest off back to the.
yeah, and if we can add in like in our own kind of like callouts and like special, like basically like a special MBD socket type thing, and then we can connect it to backend and do various things. But yeah, it just depends. So it just needs more work to pretty it up, or just do more research into what exactly needs to be done and things like that.
Yeah,
I guess it would be nice if the NBD runner or whatever we call it was structured in such a way that if and when some NBD alternative becomes available, we can just sort of plot it in.
You mean
Have
for
the
user space or for the kernels or the tooling or the all of it, I guess?
The user space daemon. Like we're gonna have some interaction with user space daemon to like, please map this image and tell me when it's ready, or and tear this one down or whatever. It might be nice to have that. Maybe it's not worth it because it's all going to be hidden by this RBD CLI, I guess, at the end of the day, right? The RBD CLI is going to do a map, and it's going to either have the daemon do it for you or it's going to do it itself. So
yeah.
Okay. Anyway. All right. Cool. Good.